Good morning, guys. While you're gone, we're going to be doing section 4.6. And what we're going to be studying are two different ways to come up with an estimate of area underneath the curve. And the first one is called the Trapezoid Rule. Earlier on in the year, if I had a curve and I wanted to estimate the area underneath it, this is before we discovered how to actually find the area under a curve. What we did was we broke that area up into a finite number of subdivisions, and then we created rectangles using either the left hand or the right hand side, calculated the area of each rectangle, and added them all together. Well, as the name implies, instead of using rectangles now, we're going to be using trapezoids. So if I start drawing in the tops of these trapezoids here, what you can see is that the trapezoid more closely models the curvature of the function that we're trying to find the area underneath. So using the same number of rectangles, the trapezoid gives you a better estimate than rectangles. Now, there is a formula that you need to memorize for the trapezoid rule. I'm going to give you that now, and then we'll work through a couple, one or two examples. So let's get rid of this. And here is the formula. Now, by the way, if you look in the book, it shows you where this formula comes from. I'd be happy to show it to you when you get back if you're interested. But for now, you can take my word for it. It's b minus a all over 2n. N is equal to the number of subdivisions. The book will give you that. It'll tell you how many subdivisions to break it up into. Obviously, B and A are the endpoints along the x-axis. Now you're going to multiply this by a long sum. So stick with me here just for a second. You're going to start with f of x sub 0. That's the far left-hand y value, or like the height or the first base of the first trapezoid, plus 2 times f of x sub 1 plus 2 times f of x sub 2. And you continue that pattern all the way out to 2 times f of x sub n minus 1 plus 1 times f of x sub n. So as you can see, the two ending y values are not multiplied by 2. Every other value in between is multiplied by 2. And these f of x's are just y values. All right, remember, you can always pause this. You can go back a page. You can fast forward if you need to spend more time on it if I'm going too quickly. So let's use this trapezoid rule formula then and apply it to an actual problem. Let's say that I've got the integral from 0, let's go to 3 of x squared dx. And then we want to use 5 subdivisions using the trapezoid method. All right, so here we go. First of all, it's right-hand endpoint minus left-hand endpoint all over 2 times 5. That's the number of subdivisions. And then in here, I'm going to start off at the far left-hand side and figure out that y value. That's f of 0. Now, remember back when we did summation, if I have a distance along the x-axis of 3 units, and it's 3 units because of these numbers right here, that's the distance from 0 to 3, and I break that up into 5 subdivisions, that means the width of every subdivision is going to be 3/5. So I'm going to work my way along the x-axis in intervals of 3/5, which means my next term here is going to be 2 times f of 3/5 plus 2 times f of 6/5 plus 2 times f of 9/5 plus 2 times f of 12/5 plus 1 times f of 15/5, or f of 3. So I start with the left-hand side, f of 0, and I end at f of 3, which is the right-hand endpoint. So it's Let's make some room here. In order to get these functional values, what you're going to do is you're going to place them, each one of those x's, and you're going to put it into the original function, which is x squared. So let me just work out just a few of these here. I'll have 3/10 out front. Inside of here, I'll have f of 0, which is 0 squared, plus the next functional value. It'll be 2 times 3/5 squared, plus, etc. And again, I'm getting those y values by plugging them into the original function. Because of time, I'll allow you to use your calculator on this. Remember to use PEMDAS, right? So you want to square these first, then you want to multiply, then you want to add them all together, and lastly, then you want to multiply by the number out front. I'm not going to give you very many of them, so you won't have to spend a ton of time on this, but that's essentially the trapezoid rule. All right, now next I have to address something before we move on here. First of all, there seems to be a problem with, let's just call it world knowledge. So bear with me for a second. For instance, this is a picture of a chimp that was drawn on a recent test. Does that look like a chimp to you? So I'm going to attach a document that will allow you to develop these skills so that you can survive in today's world. This is how you draw a chimp. The next rule is called Simpson's rule. It uses a technique similar to the trapezoid. I'm not going to show you like where it comes from. It's very hard to draw. There is a derivation of it in the textbook. Simpson's rule is another formula. It's very, very similar to the trapezoid rule. There's just some small changes. Here's the formula. It's b minus a, right hand minus left hand, but now it's over 3n instead of 2n. Now, the way I remember it is the Simpsons have 3 kids. All right, hope that helps. Inside here then is going to be, just like it was on the trapezoid rule, this is f of x sub 0. That's the far left y value. Excuse me, that's the y value of the far left bound, plus 4 times f of x sub 1, plus 2 times f of x sub 2. And this pattern of 4, 2, 4, 2, 4, 2, 4 continues all the way until you get to 4. Well, I have to do that in black. Give me a second here. 4 times f of x sub n minus 1 plus f of x sub n. So again, the pattern of the coefficients that you multiply the y values by goes 1, 4, 2, 4, 2, and it continues in this manner until you get to 1. Now it must be 1 and then a 4, and at the end a 4 and then a 1, which means that n, this pattern, can only be sustained if n is an even number of subdivisions. So I'll always give you a problem with an even number of subdivisions for Simpson's rule, as will the book. All right, let's work a problem. Again, let's go from 0, let's go to 2 now, and let's do, I guess 4 subdivisions of x squared dx. N equals 4. On the outside it's 2 minus 0, all over 3 times 4. This is going to be f of x sub 0 plus 4 f of x, f of, now I'm going from 0 to 4, that's a distance of 2, 0 to 2, that's a distance of 2, and I'm breaking it up into 4 subdivisions, which means each one will be 1/2 wide. So that's 4 times f of a half plus 2 times f of 3/2. That's wrong. Good morning. That's f of 1, or 2/2, plus 4 times f of 3/2, plus f of 4/2, or 2. Okay, now just like in the previous example, what you do is you take these x values and you're going to plug them into the original function here. You multiply out all those products, add this sum together, and then lastly multiply by the fraction out front. So we'll just work through just a couple here. This is going to be 2/12 or 1/6 on the outside. That's 0 squared plus 4 times 1/2 squared plus 2 times 2/2 or 1 squared, etc. All right, guys. So best of luck down there. Hope you do well. Tell Mickey Mouse. Yeah, best of luck, as I said before, in the competition. I'll leave you with the chimp. Goodbye.